slope coefficient was going to be negative because the sum of the cross products is negative. And if we're dividing by n minus 1, the denominator, n minus 1, can't be negative, so the covariance was going to be negative. And the sign on the slope coefficient is determined by the sign of the covariance. What is the intercept for this regression model? How do we get the intercept? It is equal to the average value of y minus the B1 coefficient, the one we just calculated, times the average value of x. But we have a negative sign on this, so we'll end up adding. So let's, here's y, here's our total y, here's our average y, 6.75, here's our average x. So it'll be 6.75 minus negative 1.3 times 7.5, which we have here. The average y minus B1 times the average x, we get 16.5. How is this estimated linear regression model represented? Well, it's y equals b naught plus b1 x model. B times b6 coefficient value for determined by the minus we just sum the slope come profit margin by using the variation he observes in the company's research and development spending. He reports the data in Exhibit 8. And there we have it, 8 companies, 8 observations for Y, which is the net profit margin, 8 observations for X, which is research Y, which is the net profit margin, 8 observations for X, which is research and development as a percentage of revenue. What is the slope coefficient for the simple linear regression model? The slope coefficient, you'll recall, was the covariance of X and Y divided by the variance of X. What do we need for a covariance? We need the sum of the cross products of the deviation. And what do we? So let's move over here. The average value of X and the average value of Y will lie on the regression line. When we use the least squares methodology to fit a line of best fit, that will be a natural outcome, is that that line will the average of Y and X will be somewhere on that line. Knowing that means we can calculate what the intercept will be, because if Y equals B0 plus B1 X1, and we say that the average of Y and the average of X will fall on the line, just subtract B1X from both sides, Y minus B1X. We'll have our sample for Y and we'll have our sample for X. We'll have the observations. We can compute the average value, and from that we can get what our intercept is going to be. We never actually have to calculate the intercept. It'll be calculated for us with statistical software. However, this is just showing you the relationship between the average value of X, the average value of Y, and the intercept. Can we calculate B1? We can. B1 is the covariance of X and Y, and again we have our observations of X, we have our observations of Y. If we run this through statistical software, the software is going to say, first thing I got to do is calculate the covariance between the X and the Y's, and then I'm going to divide it by the variance of X. So it's the covariance of X and Y divided by the variance of X. That will give us our our slope coefficient. So just by knowing the values of X and the values of Y, I can fit a line of best fit by following this methodology. I could just calculate the average of Y and the average of X. I've got my intercept. I can then take the covariance of X and Y divided by the variance of X. I've got B1, and that will give me a line of best fit.
In the previous video, we were looking at the least square method. The first step of the method requires calculating the slope of the regression line. As we understood, regression line is the best possible straight line that can be made using the points on the scatter plot. The process to make the straight line using the scatter plot points is known as least square method. Let us use the investment and profit example to make the regression line using scatter plot points. If you open the provided Excel file, in the first 3 columns, you will see the example data. The first, second and third column represent the variables year, investment and profit respectively. As per the least square method, the formula of slope is covariance between the predictor and the response divided by variance of the predictor. We will first calculate covariance inside Excel using this formula. In the fourth column, I have calculated the difference of each value of investment with the mean of investment. Similarly, in the fifth column, the difference of profit from its mean is calculated. We have calculated the mean of investment and profit at the end of their respective columns. We then calculated the product of the corresponding differences of investment and profit in the sixth column. The sum of values in the seventh column represent the covariance. For this example, we are getting a covariance value of 150. Now we will calculate the
What I want to do in this video is introduce the value of the distance, or I guess the product of the distances of each random variable from their mean, or from their expected value. So let me just write that down. So if I take I'll have x first. I'll do this in another color. So it's the expected value of random variable x minus the expected value of x. You could view this as the population mean of x times, and then this is random variable y, so times the distance from y to its expected value, or the population mean. The population mean of y. The population mean of y. And if it doesn't make a lot of intuitive sense yet, well, one, you can just always kind of think about what it's doing, play around with some numbers here. But the reality is, it's saying how much they vary together. So you always take an x and a y for each of the data points. So let's say you have the whole population. So every x and y that's kind of that go together with each other, that are a coordinate, you put into this. And what happens is, let's say that x is above its mean when y is below its mean. So let's say in the population you had the point. So one instantiation of the random variables, you sample once, I guess, from the universe, and you get x is equal to 1, and that y is equal to, let's say y is equal to 3. And let's say that you knew ahead of time, you knew ahead of time that the expected value of x is 0, and let's say that the expected value of y is equal to 4. So in this situation, what just happened? Now, we don't know the entire covariance. We only have one sample here of this random variable. But what just happened here? We have 1 minus. So we're just going to calculate. We're not going to calculate the entire expected value. I just want to calculate what happens when we do what's inside the expected value. We'll have 1 minus 0. So you'll have a 1 times a 3 minus 4 times a negative 1. So you're going to have 1 times negative 1, which is negative 1. And what is that telling us? Well, it's telling us, at least for this sample, this one time that we sampled the random variables x and y, x was above its expected value when y was below its expected value. And if we kept doing this, let's say for the entire population this happened, then it would make sense that they have a negative covariance. When one goes up, the other one goes down. When one goes down, the other one goes up. If they both go up together, they would have a positive variance. Or if they both go down together, and the degree to which they do it together would tell you kind of the magnitude of the covariance. Hopefully that gives you a little bit of intuition about what the covariance is trying to tell us. But the more important thing that I want to do in this video is to connect this formula I want to connect this definition of covariance to everything we've been doing with least squared regression. And really, it's just kind of a fun math thing to do to show you how, well, to show you all of these connections and where really the definition of covariance really becomes useful. And I really do think it's motivated to a large degree by where it shows up in regressions. And this is all stuff that we've kind of seen before. You're just going to see it in a different way. So this whole video, I'm just going to rewrite I'm just going to rewrite this definition of covariance right over here. So this is going to be the same thing. So this is going to be the same thing as the expected value of, and I'm just going to multiply these two binomials in here. So the expected value of our random variable x times our random variable y minus, well, I'll just do the x first. So plus x times the negative expected value of y. So I'll just say minus x times the expected value of y, the expected value of y, and that negative sign comes from this negative sign right over here. And then we have minus expected value of x times y minus the expected value of x times this y. Just doing the distributed property twice. And then finally, you have the negative expected value of x times the negative expected value of y. And the negatives cancel out. And so you're just going to have plus the expected value of x plus the expected value of x times the expected value of y times the expected value of y. And of course, it's the expected value of this entire thing. It's the expected value of this entire thing. Now, let's see if we can rewrite this. Well, the expected value of the sum of a bunch of random variables, or the sum and difference of a bunch of random variables, is just the sum or difference of their expected values. So this is going to be the same thing. This is going to be, and remember, expected value, in a lot of contexts, you can view it as just the arithmetic mean, or in a continuous distribution, you could view it as a probability-weighted sum or probability-weighted integral. Either way, it's nothing. We've seen it before, I think. So let's rewrite this. So this is equal to the expected value of the random variables x and y, x times y. I'm trying to keep them color-coded for you. Color-coded. And then we have minus x times the expected value of y. So then we're going to have minus the expected value of x times the expected value of y, of x times the expected value of y times the expected. Then you're going to have minus the expected value of this thing right over. Think about it as known. So things that already have the expected values, you can kind of view these as numbers. You already view them as known. So we're actually going to take them out of the expected value, minus of x, expected value of x. Think of it this way. You could view this as the population mean for the random variable. So that's just going to be a known, it's out there, it's in the universe. So the expected value of that is just going to be itself. If the population mean or the expected value of x is 5, done. This is just going to be the expected. So let me do this is just going to be a number, expected value of y. So we can just bring this out. If this was the expected value of 3x, it would be the same thing as 3 times the expected value of x. So we could rewrite this as negative expected value of y
We'll be on the topic of multiple regression for the next few modules. And our task over those modules is pretty simple, pretty straightforward. We're going to specify the regression model that we'll be using and interpreting the output. We don't actually have to calculate the output. That's done for us because it's way too involved to begin to do it by hand. There are some things that we'll look at that we may be able to calculate by hand based on the output that we have, but typically all of the things that we calculate, and we'll do some calculating, all of those things we can calculate are part of the regression output. We can simply ask for them, and our job is to interpret them. It's easier to interpret things sometimes when we can see exactly how they're calculated, so intuitively in our head we can say, I know how that number was arrived at, it makes sense to me. So multiple regression is used to identify relationships between variables, to test existing theories. Does a combination of these independent variables have anything to say about a dependent variable, and to forecast the value of a dependent variable. And depending on what we're trying to get done, we will have a goodness of fit measure that may change based on what it is we're trying to do. Here's our regression model. You've seen a simple linear regression model, which I'll just do this here. There is your simple linear regression model, which only has one independent variable. Well, multiple has multiple independent parts for the standard error estimate. If this is our violation, k refers to the slope coefficients. K plus 1 includes the intercept. When we include the intercept, slope coefficients. What does that mean? It means, let's just take B2 and X2 right here. It means that what the value of B2 is the effect that X2 has on the dependent variable holding all other change in X2 that would be variable expression. Once we decide we have a continuous dependent variable, we estimate the regression model, and then we look at the residuals. Because if we have violations of regression assumptions, that's as far as we can go. There's no point in going down here and examining the goodness of fit. You got to stop. So we're asking, are the assumptions of regression satisfied? If the answer is no, you adjust the model and you re-estimate, and you keep doing that until you get a yes. If you get a yes, examine the goodness of fit. Is the overall fit significant? Maybe it's not. Maybe you have some independent variables and you test the model. There are no violations. You look at it, you go, yeah, but it doesn't do anything. Well, then start over, right? If it does, great. Is this the best possible model that you have? Coefficient measures the change in the dependent variable for a 1 unit change in the independent variable, and this is the important part here, holding all other independent variables constant. Now you may point out in a regression model, you may say, well, I've got two independent variables.
linearity, and if it is, the question is that the result come to the third requirement, which is homoscedasticity. A requirement for the linear regression is that the residuals have a constant variance. Since our regression model never exactly predicts our dependent variable in practice, we always have a certain error. Now we can plot our dependent variable on the x-axis and the error on the y-axis. The error now should scatter evenly over the whole range. If this is the case, homoscedasticity is present. If the result looks like this on the right side, then we have heteroscedasticity. In this case, we have a different error variance depending on the value range of the dependent variable. If this is the case, the requirement for a linear regression is not met. So, and before I show you how you can check the assumptions online, we come to the last assumption, which is no multicollinearity. So the first question is, what is multicollinearity? The second case on the right side, however, we see that there are meaningful large. This is usually done graphically. The second requirement is that the error epsilon
So in this video, we're going to talk about finding a QQ plot. So I'm going to use an example of data from Steph Curry. He's a player formerly he was in the Toronto Raptors. He moved to Golden State Warriors for the Toronto Raptors to beat them. He's known for shooting three-point shots and racking up quite a few points per game. So I took a simple random sample of 6 games, by which I mean I actually just made up this data, but that's not important. We're going to pretend this data is how many points Steph Curry got out of 6 randomly sampled games of basketball. And we're going to make a QQ plot to determine whether or not these 6 values follow a normal distribution. I'm going to be using the R programming language. This is not something that you need to know for this course. This is just something I'm going to use for this example. So we'll start by defining Curry as these 4 numbers. In R, if I want to see the name of something, I can just type the name of it and it will show me exactly what I assigned to it. For the purposes of a QQ plot, we actually want to sort them first. And I can do that myself, but I'm lazy and I'm going to get R2. And this is the sorted data. So when I make this QQ plot, this is actually going to be my y-axis. So there's something I'm going to say 38 is the lowest value. 2 above that is 40. 3 above that, so I'm going to go a little bit higher, is 43. Approximately the same distance there, 46. Hopefully, I'm drawing this approximately to scale so that this is a distance of 2, that's a distance of 3, and then 58 is way up here. Now, in order to figure out what I want on the x-axis, what I need to do is figure out what is the quartile, or what is the quantile of 38. 38, in terms of the sample, I want to know 38 is the 5% quantile, is it the 20% quantile? I can calculate some quantiles by hand, so like the median is going to be the middle number, which is in between 43 and 46. So the median of this data should be 44.5, but that doesn't actually help me. I need to know what is the quantile of 43, what is the quantile of 46, what is the quantile of 49. Um, just like with calculating the median, it doesn't matter what the actual values are, just that they are in order. It doesn't matter for all of the quantiles. So R has a function that will tell me what, if I tell it I have 6 values, it will tell me what those quantiles are. P points is the name of it. So the first quantile is 10%, so this 38 corresponds to the 10% quantile. 40 is the 20 that myself, but I'm lazy and I'm going to get R2. This, we're going to pretend this data is how many points Steph Curry got out of 6 randomly sampled games of basketball. And we're going to make a QQ plot to determine whether or not these 6 values follow a normal distribution. I'm going to be using the R programming language. This is not something that you need to know for this course. This is just something I'm going to use for this example. So we'll start by defining Curry as these 4 numbers. In R, if I want to see the name of something, I can just type the name of it and it will show me exactly what I assigned to it. For the purposes of a QQ plot, we actually want to sort them first. And I can do that myself, but I'm lazy and I'm going to get R2. And this is the sorted data. So when I make this QQ plot, this is actually going to be my y-axis. So there's something at, I'm going to say 38 is the lowest value. 2 above that is 40. 3 above that, so I'm going to go a little bit higher, is 43. Same, approximately the same distance there, 46. Hopefully, I'm drawing this approximately to scale so that this is a distance of 2, that's a distance of 3. And then 58 is way up here. Now, in order to figure out what I want on the x-axis, what I need to do is figure out what is the quartile, or what is the quantile of 38. 38, in terms of the sample, I want to know 38 is the 5% quantile, is it the 20% quantile? I can calculate some quantiles by hand, so like the median is going to be the middle number, which is in between 43 and 46. So the median of this data should be 44.5, but that doesn't actually help me. I need to know what is the quantile of 43, what is the quantile of 46, what is the quantile of 49. Just like with calculating the median, it doesn't matter what the actual values are, just that they are in order. It doesn't matter for all of the quantiles. So R has a function that will tell me what, if I tell it I have 6 values, it will tell me what those quantiles are. P points is the name of it. So the first quantile is 10%, so this 38 corresponds to the 10% quantile. 40 is the 26% sample quantile. 43 is the 42nd quantile, and so on. Okay, get that out of there. So this is telling me the smallest value of my data set is the 10% quantile, and so on. Now, what I want to know is something equivalent for the normal distribution. So in order to do that, I can use the qnorm function, qnorm of p points of 6. And so this is going to be slightly hidden by my data, but it's giving me what the theoretical quantiles are. So if I have 6 data points, doesn't matter what those data points are, I have 6 data points. The lowest one is the 10% quantile. The second lowest one is the 26% quantile. The third lowest one is going to be the 42% quantile. In a normal distribution, if I convert that based on what we have for normal distribution, I get negative 1.28. I've got a point at negative 0.64. at negative 0.2. And then I'm just going to draw the tick marks going from that. Actually, I'm going to redo that so that they're not equally spaced. So negative 1.28 there. I'm going to put 0 here just to help myself figure this out. So about halfway through is 0.64. And then pretty close to 0, closer to 0 than 0.64 is negative 0.2. And then it's just mirrored on this side. I just want to get the distances right. So now I have my x values and my y values set up, so I can just put a point at negative 1.28. Oh, I have that wrong actually. Negative 1.28 and 38, and then negative 0.64 and 40, negative 0.2 and 43, 0.2 and 46. This would be 0.64 and 49, and then this one's way up here. So if this were to follow a perfect normal distribution, I'm going to change colors to green for perfect normal. It would be, all of these points would be directly on a perfectly a line with 0 slope and 1 slope, 0 intercept. But we have this problem here. We have a little bit of an outlier in this data set. And so it's not perfectly normal. With data this small, it's never going to be perfectly normal. But what could happen if instead of this value, changing the color here, just give me a second. It did not change. This value for the 6th one, oh, I'm still on eraser. Why is that? Here we go. Sorry, figuring out how to do this. Ooh, Zoom is fun. Okay. So this last value, it was originally 58. It doesn't need to be that value. It could have been anywhere from here. It could be here. It could be here. It could be here. It can only be at minimum the second largest value, since the largest value is always going to be bigger than the second largest value. So the minimum is here. You can see how the QQ plot looks different if we have something like an outlier above. Really large outliers are going to go really high. On the other side, we can have really small outliers very far in the negative direction. The quantiles on the x-axis for the normal distribution aren't going to change. So it's always going to be at negative 1.28, 64, negative 2, 2, 64, and 1.28. These are always going to be the x values. If we change these y values so that we have really small ones here and then we get really big ones up here, you can see it becomes a little bit of an S curve, or not so much an S curve, just actually, I did this a little bit wrong. You can see if all of them change proportionally, then the line changes proportionally, and it doesn't actually change how normal it looks. If only a couple of them change, this is when we get this S curve. So if we have big outliers in the negative direction and big outliers in the positive direction, we get an S curve. If instead this point is up here, and we actually don't have as much as small of values on the left, or I forget if it's flipping my camera here, but on the if the left are all really close up and the right are all really far away, in other words, if it's right skewed, then these points will all be really close to each other on the small side, and then they'll go up, and we get a sort of cup shape looking upward. We have positive curvature in this one. If instead the high values are all brought down, if instead the high values are all brought down, move it down,
variables, but it is unreasonable to expect that independent variable 1 can change without independent variable 2 changing. They move in some relationship to each other. In finance, you'll find that no matter what independent variables you choose, they're all correlated to some degree, so that it's unreasonable to think that they move independently, but the coefficients are just the effect on the dependent variable of the change in just that independent variable. So let's take this equation we have up here. Return to a bond portfolio equals, this is our B naught here, here is our B1, here is our X1, here is our B2, and here is our X2. If we had just formulated this equation or estimated this equation with x1, this this coefficient would be different. As soon as we add another independent variable, if it has any correlation at all with x1, and a credit spread and the bond yield will be correlated, then this independent variable will take some explanatory power away from this independent variable, so the coefficients change. And what is left of each coefficient is just the effect on the dependent variable of just that independent variable. And if we add another independent variable that is correlated with either bond yield or credit spread, it will also take explanatory power away from those independent variables, thereby changing their coefficients as well. That's the whole idea behind the partial slope coefficient, is it does not explain a change. Let's say you have a 1 unit change in bond yield, and when you have a 1 unit change, it itself may change some of the other independent variables. This coefficient does not explain all of that. It only explains the change in by, or in that independent variable. So how we interpret this here, if both independent variables are equal to 0, we can see that the return will be equal to 0.0023. If we increase the bond yield by 1, the return, because we have a negative coefficient here, it will drop by 5.0585%. And if we decrease the credit spread, this value here would be negative, and this is a negative coefficient, return would increase by 2.1901. I think that's pretty straightforward. The math of it is pretty straightforward. You just put in a value and you can calculate what RET would be, or what the dependent variable would be. The interpretation is the more important thing, is that each coefficient is only the explanatory power of that individual independent variable, even if you have the true statement of saying, but if I change x1, I know that x3 and x5 must change. The coefficient on x1 does not account for those other changes, only the change in x1. Let's look at some of the assumptions of multiple linear regression. Number one, x1. Let's look at some of the account for those must change x1. I know that x3 and x5 must change. The coefficient on x1 does not account for those other changes, only the change in x1. Let's look at some of the assumptions of multiple linear regression. Number one, linearity. The relationships between the DV and the IV are linear. Now, this is not saying they are linear. It's saying, hey, listen, we're only going to do a linear relationship here. So if there's a nonlinear relationship in the data, we're not going to pick it up. The relationship is linear. So if you're looking at your data and you see something like this between x and y, you do a scatter plot, you see something, you would say, I clearly have a nonlinear relationship in the data. Multiple linear regression is not going to pick that up. It's going to have a line that looks like this if I draw a regression line, but it clearly looks like this. So you would do one of two things. You would first transform one of the variables to make a relationship that is more linear, or you would move on to nonlinear multiple regression, which we don't cover here at all. Nonlinear would, let's say you have x1 and x2, might have a third variable, b3, that is x1 times x2, or might have a b4 that is x1 squared. So it is nonlinear, so you can map out interaction effects and effects that account for this type of pattern. So the relationship that it will model will be a linear relationship. So when you look at your scatter plots and you do have nonlinear relationships, you may want to transform a variable to make it more linear. Homoskedasticity, the variance of the regression residuals. Pay attention here, it's the residuals. These are the error terms, the stochastic component, right? The variance is the same for all observations. What that is saying is that when we plot the error terms, we should get something if this is the zero line here. Sometimes you have positive errors, negative errors, depending on what side of the regression equation it falls on. We should see something like this, where it is a constant variance. We should not see something like this, where the variance starts doing that. That is heteroskedasticity, and since it looks like it's conditioned upon the value of the independent variable, the residual related across observations. When this assumption is violated, you get serial correlation, which can be positive or negative, and that is coming up. When you combine assumption 2 and assumption 3, you get something called IID, identically and independently distributed. Identically meaning the same variance across observations, independently meaning no correlation across the error terms as well. Number 4, normality. The regression residuals are normally distributed. I don't think that needs any further explanation there. If they're random variables and they follow a particular normal distribution, we can do a whole bunch of tests against that because that is a well-defined distribution. Number 5, independence of independent variables. 2 parts to this. Number 1, independent variables are not random. That means that they have a specific value. Now you may say, well, listen, one of my independent variables, x1, is a random variable unto itself. It has a normal distribution. It is a random variable. As soon as you select a single observation of x1, that observation is no longer random. It has no variance, no deviation. It is a known value. It is no longer a random variable. So that's what number 1 means. Number 2, no exact linear relationship between 2 or more independent variables, because the matrix algebra that is used in most software packages breaks down if you have exact linear relationships. Scatter plot matrices, or a pairs plot. And this is for visual inspection of the data. Sometimes you can observe violations quite easily. Other times you look in regression. I don't even bother with these because the statistical output will tell me everything I need to know. And once you get into multiple regression, it's hard to tell just by looking at a plot, especially if you have a large data set, whether something is significant or insignificant, or if some what apparent linear relationship between the independent variables is going to cause a problem until you actually run the output and look at it that way. So I don't find it a very useful step, but we'll go through it here. Any violations will be identified statistically, not visually. So let's look at the bottom row over here. Here is our dependent variable here, the returns on a portfolio. Here's the market factor, here's the size factor, and the value factor. And we would like to see linear relationships. So here we see a positive linear relationship. Here we, if you're eyeballing, you go, I don't really see very much. Almost no apparent linear relationship. This is on the size factor. The coefficient on the size factor is significant in the output. So, you can look at it and go, well, I don't like that. That doesn't look very good. Well, looks versus, an actual statistical measurement are 2 different things. That's why I say it's not really a useful step, because I could just look over here and say, I don't care what you think you see. It is significant. It stays. Here is the value factor against the market factor and the size factor. We'd like them to be uncorrelated. The more uncorrelated independent variables we find, the better it is. All variables are correlated to some degree in finance. So whenever we add one, we do expect some correlation. We just don't want them to be really, really highly correlated, because you run into something called multicollinearity, which we will get to. So we don't really see very much here. Here is the size factor against the market factor. It looks like you have a slight positive relationship here. However, when we look at the output for this particular model, which is in the reading itself, we don't find any signs of multicollinearity in the t-statistics or in the f-stat, which means that, even though it has that, statistically it's not a problem. So visually is, I find, as I said earlier, it's kind of a wasted step, because I can get the numbers, I can get the same results statistically, and if something is a problem statistically, well, there we go, I found it. But something is a problem visually, it may not be a problem statistically. And here is a visual representation of our residuals, our regression residuals along mapped against the predicted values. And this is what we should see, this kind of dispersion. It's showing no bias to either be positive or negative. There's no clear pattern. Here, we can measure. Okay, we can really, like, up here, put time against each of the independent variables. There's the market factor, the size factor, and the value factor. And as we look at them, we don't really see any kind of relationship. They are the three elements. People take the side of the higher zigzag and the miss variable if we want normal distribution. and the monthly percentage change in the to help determine variable. You can get rid of increase in XVIX, dependent variable VIX. So this is the dependent variable. This is the independent. This is that may be zero constant, result in the 0.03 versus assumption increase in returns. Correct. Identify the regression assumption that may be violated based on chart 1, the returns versus the VIX. So this is the dependent variable. This is the independent variable here. And this question is a good reason why I don't really care for these kind of plots, because it's like technical analysis. You may see something and I may see something different. Independence of errors. Well, we can get rid of that because we are not using the error terms anywhere in here. It's the dependent against the independent, so we can't say anything about the errors here at all. Independence of independent variables. Well, this is a plot of dv against iv. For this, we would need plots of iv versus iv, the independent variables versus each other, so we can get rid of that. I can walk away with C, even if I don't agree with C. Linearity between dependent variable and explanatory variable. So we look at the plot and we say, well, it's a whole bunch of dots with dispersion. You know, it kind of looks like a linear pattern. I wouldn't expect it to be exact. I mean, maybe these are outliers over here, but it is saying that, well, if you look at it, it kind of looks like this. Well, actually, this one here would kind of look like that it looks more non-linear. I think I would have made it a little bit more obvious if that's really what I wanted to do. However, it is still a good enough question in knowing that you can eliminate A and B, and since there's only one answer, you can take C, even if you can't definitively say C without eliminating A and B. Identify which chart among charts
警花小姐姐，
2,
教你反诈
3,
遵
and
口溜
4
喽
is。most
不
likely
吃
to
辣
be
椒，
used to
不吃
assess
辣，不被骗来，
homoscedasticity.
不知诈。
Here we need a chart of the errors versus the predicted values. Here we have the dependent variable versus an independent variable, so we can get rid of A. Here we have excess returns. It's a dependent variable against another independent variable. We can get rid of 3. We have to go with 4. This is the residual, so there's our error term. This is the predicted values, and this is what we need, predicted values over here. This is y hat. That's exactly what we need chart for. Identify which chart among charts 2, 3, and 4 is most likely to be used to assess the independence of independent variables. Here we need an IV versus an IV. This is two different people will see two different between across observations. When this assumption is violated, you get serial correlation, which can be positive or negative, and that is coming up. When you combine assumption 2 and assumption 3, you get something called IID, identically and independently distributed. Identically meaning the same variance across observations, independently meaning no correlation across the error terms as well. Number 4, normality. The regression residuals are normally distributed. I don't think that needs any further explanation there. If they're random variables and they follow a particular normal distribution, we can do a whole bunch of tests against that, because that is a well-defined distribution. Scedasticity versus heteroscedasticity, we want to see that the variance is constant across the observations. When I say observations, I mean the residual for each are independent of. Number 3, independence of errors. The observations are independent of one another, and that means that the regression residuals are uncorrelated across observations. When this assumption is violated, you get meaning the same variance across evaluating model fit and interpreting results. And this is applying to multiple regression. And our learning objective is at the bottom of the screen. Evaluate how well a multiple regression model explains the dependent variable by analyzing ANOVA table results and measures of goodness of fit. The first measure we'll look at is the coefficient of determination, or the R-squared, which is one of the most popular statistics to quote when looking at a model. It has an R-squared of this, but there are some significant drawbacks with R-squared, and it's not really a good measure in terms of evaluating whether the model is a good model, whether it fits very well, because you can always get the R-squared higher by adding independent variables. The R-squared would never drop, it'll only increase, and you will overfit the model to the sample data and it won't travel very well. Well, that's not a good fitting model, even though you have a very big R-squared. And depending on your sample size, you might have an R-squared that's really not that big, but it's a good model, it fits well, and it is a significant model, only because the sample size is so large that the relationship shows up in it. So the coefficient of determination is the ratio of the explained variation to the unexplained variation. This is the sum of squares from the regression. This is what has been explained, and the denominator is the total amount of variation that needs to be explained. As you add independent variables, R-squared will increase or stay the same. It will never decrease. You can never add an independent variable to a regression that lowers the R-squared. Even if that variable has nothing to do with the dependent variable, it wouldn't do anything to R-squared. R-squared would just stay the same. It can never decrease it. It will only increase it or keep it the same. Further, we have no information within R-squared about whether or not any of the coefficients are significant, whether the model itself is significant. No information on any regression violations that may cause the coefficients to be biased. And it is a poor gauge of model fit simply because you can overfit a model to the sample data. You can get low in-sample error and say, well, I've got an extremely high R-squared. You can get R-squared to 100%. By adding more and more variables, but that's not going to travel very well. You'll have high out-of-sample error. So what we can do is every time we add an independent variable to a regression is we can penalize R-squared, which means R-squared would have to go up by a minimum amount just to overcome the fact that you added another variable. So adjusted R-squared could decrease as you add independent variables. So adjusted R-squared, we just stick a bar over R-squared to get the notation for adjusted R-squared. 1 minus the ratio here, SSE over or divided by its degrees of freedom. This is MSE in the numerator, and we have total sum of squares divided by its degree of freedom in the denominator, which simplifies to this over here, and I will show you on the next screen how to get from this mathematically to this, even though you don't need to know how. You don't need to calculate this. There's always a group of candidates that say, well, how did you get there? I want to know. Okay, this is just for your information. Some candidates like to know exactly how this happens. Let's start with this ratio over here, which is just reprinted here, and we'll take the denominator, we'll invert it, these cancel, so you'll have 1, you'll multiply the numerator by that, we end up here. We can just divide the two and put them in this form. Here is the first term over here. Let's deal with this one. SSR plus SSE equals SST. This is saying the explained variation plus the unexplained variation is the total variation. Let's divide through by SST. We'll get get this SE equals SST. This is saying the explained variation plus the unexplained variation is the total variation. Let's divide through by SST. We'll get this statement here. On the previous screen, we said SSR over SST is R squared. So we'll stick R squared in here, and we end up with this equation. Subtract R squared from both sides. Here we go. SSE over SST equals 1 minus R squared. There's SSE over SST, so we could just substitute in 1 minus R squared. Sometimes when we look at a mathematical simplification, it's not very intuitive. We can't see it in our head as to why this is the case. We can see it over here that it's the case, but not not here. So sometimes knowing that this is nothing more than this allows us to accept this and saying, well, I know what's going on there. For adjusted r squared, notice this term over here. We have n minus 1, and in the denominator we have n minus k minus 1. So if k equals 1 or more, this ratio here will be greater than 1. So if k is greater than or equal to 1, adjusted r squared will be less than the r squared value. And if the absolute value of this t statistic for the coefficient, any coefficient, whether it be b1, whether it be b2, as you add independent variables, so let's say we added x3, and we look at the t-stat for this coefficient, and we take the absolute value of the t statistic. If it is greater than 1, then adjusted r squared will increase, otherwise it will decrease. So if we're looking at adjusted r squared and we add another independent variable and we see that adjusted r squared decreased, we know the absolute value of its t statistic was less than 1. That would make it insignificant anyways. So we would know that we wouldn't add that. If adjusted r squared increased, the t statistic is greater than 1, but let's be clear, being greater than 1 doesn't make the coefficient significant. So just looking and saying, hey, adjusted r squared increased, we'll keep it in the model. Well, it just means that the value was either higher than 1 or less than negative 1, but to be statistically significant, we'd want to see it at the 5% level, higher than 1.96 or lower than negative 1.96, so it's not much of a hurdle to jump on that one. I've taken this output from the reading. We have some ANOVA output here, and we have some information on our coefficients. This particular model has 5 factors or 5 independent variables. Coefficient value, their standard error. From that, we can, from the standard error, we can calculate the t statistic. This is assuming, of course, that the value we're testing for the coefficient is 0. Remember that, right? Our p-value, and then we have lower and upper bounds, which we don't really need here. So let's calculate r squared. We have enough information. SSR over SST. This is sum of squares. Sum of squares from the regression over sum of squares total. We get 0.6155, and our adjusted r squared is 1 minus, our numerator here is n minus 1. Our n is 50. We know our degrees of freedom here are k. This is going to be n minus k minus 1, and this is going to be n minus 1. So 49 is our n minus 1. Our n must have been Between 50 and minus, our numerator here is n minus 1, our n is 50. We know our degrees of freedom here are k. This is going to be n minus k minus 1, and this is going to be n minus 1. So 49 is our n minus 1. Our n must have been 50, right? N minus 1 is 49 divided by 50 minus 5 minus 1. So it's the degrees of freedom total divided by the degrees of freedom residual multiplied by 1 minus r squared, and all of that is subtracted from 1.5718. It is lower than the r squared, so we're penalized for adding the independent variables. If we look at the t statistic, which two independent variables would you immediately get rid of without any hesitation? We would get rid of any one that has an absolute value less than 1. So factor 1, we wouldn't get rid of that. Factor 2, the absolute value is less than 1. Get rid of that because that lowered adjusted r squared. Factor 3, that's not going to be a significant t adjusted. Absolute get rid of without any hesitation. We would get rid of any one that has an absolute value less than 1. So factor 1, we wouldn't get rid of that. Factor 2, the absolute value is less than 1. Get rid of that because that lowered adjusted r squared. Factor 3, that's not going to be a significant t squared absolute value. And a penalty factors 1, 3, and 4 because their absolute value of the t statistic is greater than 1. The adjusted r squared will decrease with factors 2 and 5. And as a bonus, we can also say they are also insignificant. So if we have a regression with factor 1 and we add factor 2, we look at factor 2, absolute value less than 1, we know right away our adjusted r squared will decrease. If we add factor 3, since its absolute value is greater than 1, we know adjusted r squared will increase. Same with factor 4, add that, adjusted r squared will increase. We add factor 5, we could just look at this and right away we know that adjusted r squared will decrease. So for the adjusted r squared, there is no intuitive explanation in terms of the percentage of variance explained. R squared is a very direct interpretation. Adjusted r squared, not really. No information on coefficient significance or potential coefficient bias, and it is not a goodness of fit measure. Going into better measures, we'll look at AIC and BIC. This is Akiki's. I think the statistician's name was Hirotagu Akiki. Akiki's information criterion, and we'll look at Schwartz's Bayesian information criterion. They're basically the same except for the penalty term. This is a penalty term here, and here it is here as well. The Bayesian information coefficient has a greater penalty term, a larger penalty term. Everything else up here is the same in both. It just assesses a larger penalty term. Akiki's information criterion, or AIC, evaluates a collection of models that explain the same dependent variable. So we have n times the natural log of the ratio of SSE over n. SSE is the sum of the squared errors, and we're just dividing by n here. So that's not the mean squared error because we're not dividing by the degrees of freedom, we're just dividing by the sample size. So it's just an average squared error per observation. Obviously, the lower the SSE, the better the AIC is going to be because we're trying, like a golf score here, to get a lower AIC. Same with the BIC. You can think of this as a golf game and we're trying to get a lower score. Adding independent variables may lower SSE, but it can never raise it. So as we add an independent variable, either it will lower SSE or do nothing. Here's our penalty term. If we add another one and we lower SSE, this first term gets lower, but we're adding the penalty term over here. Bayesian information coefficient says, yes, add the penalty term, but don't just multiply k plus 1 by 2, multiply it by the natural log of the sample size. And since the natural log of the sample size is going to be greater than 2, BIC assesses a greater penalty. Okay, AIC, better for prediction purposes. BIC, better when goodness of fit is preferred. And you may be thinking, that doesn't tell me a lot here. Better, and since the natural log of the sample size is going to be greater than 2, BIC assesses a greater penalty. Okay, AIC, better for prediction purposes. BIC, better when goodness of fit is preferred. And you may be thinking, that doesn't tell me a lot here. It's rather confusing. Wouldn't I be predicting with almost anything? And what's the difference between having a model that's a good predictor and one that has a good fit? Let's take a number of industries, 1, 2, 3, 4, 5. And we're trying to explain the performance of the industry, the return on the industry. Let's say we add all the stocks in this particular industry into a portfolio, a market cap weighted portfolio, and look at its return. And we do the same with this industry, return 1, return 2. And we want to develop a model that can predict these particular returns. But we have 5 different industries. So if we want a general model that we can then apply to each particular industry, well, we're looking for goodness of fit. We would probably evaluate that model with the BIC. When we take that model to this particular industry, we may find that there are independent variables that are industry specific that work here, but if we added them to this model over here, would not work very well across these other industries. So we can use the BIC for a more general model, across all industries and use the AIC to evaluate a model that is industry specific or more particular to the environment that it's in, so that we can add independent variables to the model we developed here that are more industry specific and use this as our measure of fit rather than using the BIC within the industry. So let's have a look at what we have here. This is what we had a couple of screens ago, the same model that we're at. Return one, return the portfolio that has a good fit. Let's take a number of industries, 1, 2, 3, 4, 5. And we're trying to explain the performance of the industry, the return on the industry. Let's say we add all the stocks in this particular industry into a portfolio, a market cap weighted portfolio, and look at its return. And we do the same with this industry, return 1, return 2. And we want to develop a model that can predict these particular returns. But we have 5 different industries. So if we want a general model that we can then apply to each particular industry, well, we're looking for goodness of fit. We would probably evaluate that model with the BIC. When we take that model to this particular industry, we may find that there are independent variables that are industry specific that work here, but if we added them to this model over here, would not work very well across these other industries. So we can use the BIC for a more general model across all industries and use the AIC to evaluate a model that is industry specific or more particular to the environment that it's in, so that we can add independent variables to the model we developed here that are more industry specific and use this as our measure of fit rather than using the BIC within the industry. So let's have a look at what we have here. This is what we had a couple of screens ago, the same model that we're working with. We noted that if we added factor 2, our adjusted R squared would decrease because it had an absolute value on the t-stat of less than 1. And then we have an increase when we add factor 3. We have a significant increase when we add factor 4. And then we decrease again when we add factor 5. We look at the AIC. We look for the lowest one. Here it is. It is telling us that it's factors 1, 2, 3, and 4. Whereas for the BIC, we're seeing that it is factor 1 only. Before you get too excited about this, we did not test a model that had factor 1 and 4. Factor 4 really increased adjusted R squared. So I would seem to think that I would want to generate a model with only factor 1 and factor 4 and compare it with all of these. I am certain that if I did this, I'd get a lower AIC than this one, and I'd probably get a better BIC on 1 and 4 as well, with the AIC and BIC being in confirmation of each other for that model. But we didn't do that. We just did an incremental model, adding one independent variable at a time. Hypotheses testing. This R squared will increase or stay 100% by adding. Okay, just to overcome the 100% by adding more and more variables, but that's not going to travel very well. You'll have high out of sample error. So what we can do is every time we add an independent variable to a regression is we can penalize R squared, which means R squared would have to go up by a minimum amount just to overcome the fact that you added another variable. So adjusted R squared could decrease as you add independent variables. So adjusted R squared, we just stick a by its degrees of freedom. This is MS in the numerator, and we have total sum of squares divided by its degree of freedom in the denominator, which simplifies to this over here, and I will show you on the next screen how to get from this mathematical, just as t is up, it is that it can never raise it. So whereas for the BIC, we're seeing that it is factor 1 only. Before you get too excited about 4 and compare it with all of each other for that model, but we didn't do that. We just did an incremental model, adding one independent variable at a time. Hypotheses testing. This is the same that you've seen in simple linear regression. For a single coefficient, you're looking at the t-stat versus the critical value, and these are your hypotheses, your null and your alternative under every case, whether you're looking for equality, two-tail test, a right tail test, and a left tail test. And we know that it is the alternative that determines the direction of the test. Here the arrow is pointing to the left, that's a left tail test. Here the arrow is pointing, the greater than sign, right? The arrow is pointing to the right, that is a right tail test. For any statistical output, the default output tests at alpha of 0.05 and tests the value of the coefficient, the hypothesized value, as being 0. But it also gives you a p-value, so you can assess the significance. You just have to look at the p-value and you can tell at what level of significance it is. If you want to test for something different than 0 on the coefficient, you'll either calculate a t-stat and compare it to its critical value, or you can simply look at the confidence interval that is put out. So let's say that you have a coefficient that is significant. Its confidence interval might be 0.06 to 2.22. Notice that 0 is not in the interval. So if 0 is not in the 95% confidence interval, we know that it is different from 0. So if you're testing if the coefficient is different from 1, well, 1 is within the 95% confidence interval. So no, it's not significantly different than 1, but it is significantly different from 0. So the confidence interval will tell you the range of values over which the coefficient is not statistically different than. Okay, on the previous screen, we tested single coefficients. We just coefficient is not statistic compared against a critical value, and it's an up or down, accept or reject. What if we want to test a number of coefficients jointly? So look at the first model we have here. It has 5 independent variables. This will be called our unrestricted model because we're not restricted
Lower, that's it. But the S&Ps, they've had a nice rally, almost 50%. I'm sorry, yeah, almost 50%.
Yeah, almost 50%. Yeah.
Yeah, I don't like that when it comes back, when the S&Ps come back almost 50%.
Yeah,
on a big down
volatility
day.
doing the same thing. I mean, NASDAQ's only, well, I guess the NASDAQ's rallied 100 too. Yeah, I guess so. Yep.
These are the kind of days that really, it kind of mess me up. I mean, first of all, I got a bunch of trades on this morning, so I'm not upset about that. But these are the kind of days that mess me up because when they're down 60 points at 10:30 in the morning and volatility's up, almost 10%.
Oh, you had everything confirming that we were going to stay weak.
Like, I didn't get short, but I wanted to. And, I mean, I guess thank God we didn't, but, man, that's a tough one. That's a tough one. This is just one of these markets where they're clearly not ready to die yet. Clearly not ready to die. I'll just leave it there.
No, not at all. Worst sell-off ever.
You know what? It kind of is the worst sell-off ever. Yeah,
That's
I'm just looking at a bunch of... Yeah. It's kind of the worst sell-off ever. It was looking like a good sell-off this morning, and then they just, decided to make it into the worst sell-off ever. Well said.
Yep.
All right, what else you got for me?
Wow, not a lot. There are some stocks percolating with some implied volatility, but they all have earnings. If you look at the last 5-day change, Qualcomm's volatility up almost 8% over the last 5 days. Starbucks, the same. PayPal, AMD, which you just mentioned, up 7%. I'm talking about implied volatility. So you do have Apple's volatility percolating too. You do have some stocks. AMD, I guess, would be the best. It's got a good high IV rank. It's got good markets, decent monthly implied volatility if you don't have anything in there, and earnings not until August 1st. So AMD might be on the radar.
Yeah, like I said, that was one of my biggest losers today, and that's only because they just pumped in some vol in there. Yeah, I'm just looking for some other underlying. No, coin, I'm just flattening out just a little bit of buy the guts, sell the wings, just to widen out the spread a little bit.
You weren't that active today.
I was not active at all today. This was one of my absolute slower days, and you know what? I just didn't. I know it's going to sound weird. I kind of didn't feel it.
Didn't feel like trading. Didn't feel like you knew where the next move was.
I didn't feel like there was no point during the day where I felt like, oh man, this is something I got to jump on, or like I would have done more new trades, but I never felt like this is something I needed to, needed to do something.
Tesla down 5 today. Can you finally put a fork in it?
No chance.
No chance.
No.
Earnings July 19th.
Absolutely no chance. Tesla, let's see.
0.
I mean, Tesla was one kind of our big winner today, but no.
So you need the little move.
I don't know what I need in Tesla. I kind of need the stock to sit right here for another month.
Chances on that happening? Less than 0.
Pretty much 0. Yeah. No, I was awfully quiet today. So, what time is it? 2:39. Okay. Yeah, it was just it was that weird slow day. I don't know how many S&Ps trade. There was like 1.4 something like last time I looked, but I don't know if it's still around that number.
Yeah, 1.46. Remember yesterday we only had less than 1 million at this time when we were talking about the market right around
I'm actually surprised by how quiet this week was. I thought because it was a short week that they would be, there'd be people would be firing, but I still believe there's a ton of speculative capital out there. I just don't, for whatever reason, think anybody, did
we had
anything.
A good 60 handle move today. I mean, we had a, I'm talking top.
I understand. I just don't think it was that interesting. That's all. I still think there's way too much money flowing into these same few stocks. It seems kind of ridiculous to me. Really does. But you know what? I learned a long time ago that it doesn't matter what I think.
Do you think it's because the new beret doesn't like give you your powers yet or anything like that?
It's a little bit
Got a
there.
couple people asking via email.
Yeah, they're not. I don't have all my powers yet.
You don't think you have the powers in
no,
there yet? You don't know
no.
if you believe in the beret
No,
that you have?
I don't mind the gray. I just
No, believe in the beret that you have.
believe in the beret.
Yeah.
I'm not all there yet.
Okay.
You know,
That's fine.
But I got a lot of complaints this morning about not wearing it, so I had to put it on. You know, a lot of.
You didn't get the same complaints I got. I can guarantee you that. Mine were a lot more savage than what you got.
Yeah, I can believe it. I can believe it.
Tomorrow's Friday, Sosnoff. Do you know what that means? I know you're leaving for D.C.
I don't know what July 7th means. Why? What does it mean?
Fast Market.
Oh, okay.
Yeah, Fast Market. Let's put the little art card. There you go. tastylive.com/Fast Market. Submit your trades to us, and Tom will look to put on 10 for 10 trades. I expect nothing less.
We did 9 the other day. We did 10 last week. We've been pretty active on Fast Market. So I was at the car wash the other day, and there's a buddy of mine.
In the rain.
What?
When it was raining.
It was overcast, drizzly, and there was a buddy of mine there. I can tell the story. It's a buddy of mine, and he's a guy that used to stand pretty much next to me in the OEX pit for a number of years, right? And at first I was
Remember
like,
his name?
Yeah.
Okay.
Yeah, his name's Tom. It's I can remember his name.
Easy for you to remember.
But when I first walked in, I was like looking at him like weird, you know. He's like, yeah, and then anyway, so we stood next to each other for many years in the OEX pit with one person away, whatever, and he's still trading for a prop firm. He's managing some funds for a prop firm, whatever. Anyway, so he goes, I still watch the show every day.
Oh, that's awesome.
He goes, I got it on
Appreciate your
background.
support.
And yeah. No, I love it. So I go, I love it. He goes, yeah. He goes, because I can't find, he goes, I just listen to the chatter between you two idiots all day. And he goes, it makes me feel like, it makes me feel good. And
Makes
he
him
goes,
feel intelligent.
And he goes, and the other thing is, he goes, I know you're going to think this is crazy, but like,
I really like that Batista kid.
No, he didn't say that.
No.
He said, he goes, I watched the show where all the different trade ideas come from the customers. He goes, I put a crazy amount of them on, all things considered.
They're not bad.
He goes, it's not that they're good or bad. They're just things I didn't think of myself.
Sure, I know, they're not bad. Yeah,
and
right.
he goes, they're all in the same vein. Like it's like I don't do anything I don't want to do anyway. So it's not like
Right.
I don't care. Right. He goes, I only do the stuff I want to do. But he goes, it's funny. He goes, I'm surprised over the last couple of years how many trades I put on watching Tasty just from
because somebody else came up with an idea.
Your guys' trades,
right?
Like just the customer trades, and I'm like, well, it's good to know,
It's good to know.
I go, does anybody else in your office watch? He goes, yeah, they do, but they don't really. It's not the same,
Let's be quite frank. I mean, even on the floor, you would get ideas from other traders, whether it was the same trade or not. You say, what are you doing? They would say, oh, I'm selling these puts at 440, and you say, oh, those puts are trading 440 or 450, whatever the case may be. And you go, oh, well, I could do this one against that one, and I would do something else. So you always came up with different trades by listening to other people. Otherwise, somebody just stand there, you do nothing.
Yeah, well, I always had a rule, a really important rule. Well, I learned this after like 10 years on the floor.
This is going to be
how much
good.
money it costs. My most important rule was never listen to Jules. Whatever he does. And then if you
I
forget.
knew this was going to be good.
Rule number 1, never listen to Jules. Rule number 2, never forget rule number 1, because that kid will take me down. But that I learned for sure. That was a big part of my success over the years. Never listen to Jules.
You have a W trade. That my friend Ryan got you involved in.
Yeah, I did.
Yeah, the 65.70. The stock's down $7 today. So he suggests...
We are long the 65.70 put spread.
That's correct.
I'm going to close that position, Ryan.
That's right. You're up $1 on the whole trade. Pretty close.
I find it absolutely
amazing. 85,
I don't
90.
usually do long debit spreads.
And I gotta be honest, I know Ryan for a long time. He's emailed me for a long time.
Never
this
had a winning
could be
trade
the
ever.
first time he's correct. That's correct. That's
You're
on
right.
W.
You're right.
When the spoons were down 65, he sent me an email thinking close all watertight doors, or 62, and I figured that was time to buy him. That's why I actually bought him.
W is a crappy stock to trade, just so you know. Like, I'm going to have to give up like 5 cents to get out of this trade.
Oh, not 5 cents. I mean, you throw around those nickels like manhole covers.
Maybe more. I can't even get out of this trade.
Well, knowing you, you're probably doing it the wrong way. So let me take a look. You were doing it
I
the
was
wrong
not
way.
doing it the wrong way.
You were doing it. You're doing it the wrong way.
How do you mean? I'm selling a vertical.
You were doing it the wrong
I
way
wasn't.
again.
You're out of your mind.
Unbelievable.
I had to give up 6 cents to get out of that trade.
6 cents. It killed you, didn't it?
It did kill me, but that was W. That was a nice trade. Wayfair. Yeah, we bought a put spread in there for.
Yeah, you said something horrible about how all the product sucks at Wayfair. It's
Oh, they do
disgusting.
suck. I hate
Outdoor furniture
Wayfair.
stinks.
$2.99, sold it for $3.84. That is the first time we got one of those debit spreads, right? But Wayfair had this crazy move. The reason I did it was hyperbolic. And it finally came back down, an actual put spread that worked. Put it on the board.
Yeah, it's a good one. It's a good one.
Yep.
Look at you. Selling triple tops. Unbelievable. You're so good at this.
Selling triple tops, buying triple bottoms. Nice job in Wayfair. There's another trade that a bunch of people got us into, which was selling the August 26 puts in. Selling the August 26. Oh, what spread do we do in
You
VXX?
just give me the stock, I can help you.
VXX.
VXX, gotcha. You did the July AUG spread.
July AUG.
I think you're on.
No, I'm in August, September right now.
Oh, so then you rolled it.
Yeah, but I don't remember what the original trade was. I have a lot of long delta in there.
You had the 20. You had the 25.27, and you made it to 20. Then you
25.27 in long the 25 and set. I'm just short the 26 puts. That's what it is. And we're short the 26 puts in.
VXX is up $1.50.
Yeah, I should have done this earlier, but it's time. This was another trade that was not my original trade. This was a trade from. I bought back the 26 puts, and we're also long a couple of the SEP 25 calls.
Long calls, short puts. That's called a stupid.
Yeah, I know. We're going to sell those out, just the extra ones. A bunch of extra ones. There you go. And that makes us flat VXX. We have a diagonal in there now. So those were two trades from What's Your Assumption? They were both pretty good.
Good. I'm glad that worked out for you.
Yeah. I'm trying to see if there was anything else in What's Your Assumption, but I don't.
Very happy for my lord. Couldn't be more ecstatic for you.
There is another What's Your Assumption trade, which I did not like the other day, but it actually worked out because a couple people got us short. But in a What's Your Assumption trade, they had to sell a call spread in Uber Goober. Do you remember that trade? And this is what I love about customer trades. They sell a call spread at 70 cents. The
47 and a half, 50?
Yes, you know where it's trading today?
30 left, 50% of what it was.
30%, 35
cents.
cents. 50% of max profit just took it off.
Yeah. Nice.
Those are three trades from just last, I think of last week.
Yeah, 628, 629, yeah.
Yep. Looking around, I don't remember.
Good job out of you. Good job out of you.
Yeah, I don't remember the other.
I hope you're saying people are going to submit orders for Fast Market tomorrow.
I hope so too. Let's see.
You guys are winners.
No, not that one. I don't remember the other ones, so I can't. I didn't look. I should have looked earlier, but I didn't look. Anyway, other than that, what else you got for me? That's three closing trades. I'm happy about that actually.
Levi, my friend, just told me has earnings tonight. Only monthly options. July 6th. He is correct.
Which one?
Levi Strauss.
Levi.
Never traded in my entire life, but
Is the yeah? I think is it LEVI? Is that the symbol?
LEVI, like Levy. Yes.
Yeah. I don't believe I've ever traded it. Does it? How much volume did it do today?
IV rank of 48, 3 million shares, nickel wide markets.
I'm gonna pass.
I would pass too, but I just figured since they took the time to send it to me on Twitter, I would mention it to you.
You got it. All right.
You want to quickly talk about what you're going to do this weekend?
We have a couple of seconds. We have a couple of free seconds, so let's talk. because there are only 2 days left to sign up, and I'm leaving tomorrow. So if you'd like to come out, last chance. Futures Options Symposium, Washington, D.C. If you hadn't heard it, I actually found somebody today, emailed me, goes, I just heard it on the show this morning. I'm like, well, we've been saying it for 2 months. But he goes, I'll be there. But anyway, Howard Theater, Saturday morning. You have to sign up online just so you get an electronic ticket to come in. It doesn't cost anything, and we can't wait to see you there on Saturday. tastylive.com/events. Myself and the Mole Mat. Saturday morning, Pete's doing from 9 to 10. I'm doing from 10 to 11, and we've got a absolutely packed content-wise show for you. It is heavy. Not gonna lie, it's not the easiest show we've ever done, but it's heavy future stuff. And if you've ever wanted it, really good future symposium, this is it. So we'll see you in Washington on Saturday. Looking forward to it.
I know you were the cause of COVID in New York when it broke out there. Are you what infectious disease will you be bringing to DC?
I have a couple of infectious diseases in my body right now, so I think I should be pretty good about starting the next pandemic.
Sweet.
When they don't have to worry about looking for the source, this one will be me.
I like it.
Super spreader for sure.
Yes, super spreader for sure.
No, I feel good.
You sound great.
I'm getting over the cold, but I feel fine.
You look amazing.
Yeah, that's what they say. Anyway, all right, take this down, please. Please. Perfect. All right, what else you got going into last call today?
Wow, limping it to last call, right? I mean,
S&Ps are down 36. They've been trading here for like the last 2 hours.
Yeah. I too liked them when volatility was a lot higher, and at least looked like we were going to get something to do. I didn't think it would be squashed so fast, volatility. I thought we would hang in there for the next couple of days, go into the weekend, but no siree. Oil hanging out at 72, closed near its highs for the week, or just about. Gold down 10. Not too much volatility going on there except for earnings. So what do you think about this earnings season? Do you ever look at it that way? Does it matter? You got a lot of bank stocks coming out first with some airlines. So you got airline stocks that have been doing very, very well. You got some bank stocks that have been doing very, very
I mean, I don't know. It's kind of weird to me, but I kind of feel like everybody's going to have good earnings. I think that the economy's been buzzing along. There seems to be so much money out there. It's like something ridiculous. I don't know. I just feel like it's just like we're in this, we're in a stage where everybody wants to be a hater, but I don't really get it.
Well, you got the Wells Fargo, Citigroup, J.P. Morgan of the world.
Well, I wouldn't touch Wells Fargo with your money.
Right.
And, Citigroup, J.P. Morgan, it's not like they're cheap, that's for sure. I don't really care about those. The problem with really low volatility and bank stocks, which have low volatility, is that
it's a double whammy when you look at the sell premium.
Right. It's a premium seller. If you want to get long JP Morgan, sell some naked puts. If you want to get long Citigroup or Wells Fargo, sell some naked puts. I actually don't like selling both sides of that market. And I also think the Russell is grossly oversold.
And it has been for some time.
Yeah, right. So I don't think I'm going to be really aggressively selling both sides of the bank earnings. I just don't see it. And we currently only have a JP Morgan position on. And I got to tell you, JPM, here it is right here.
Down $1.34, IV rank of 11 with the earnings coming July 14th.
Yeah, we have we have a crap position on.
JPM was $2 lower than this, 141 and change. It's 140.
Yeah, we have the 140 put calendar on. It's an absolute garbage position. I will take that position off before. We did it for 79 cents. It's trading for 86 cents. We're up 7 cents on it. It's one of those positions, we call them like holders, just so they can, just so you can have something that, that's in your portfolio, and it probably has 20 cents of risk either way. And we'll, if we make 10 cents on it, I'll be happy, I guess, just because it'll force me into another JPM trade for earnings. Yeah.
Volatility not really upticking much in some of the bank stocks that I've looked at. JP Morgan's an IV rank of 11.
JP Morgan.
Citigroup has an 18.
It's funny. I was talking to this guy. So I had this, we have a couple of relationships over at JP Morgan. So I was talking to this one guy, and he runs one of their new product divisions, right? And I said to him, I go, with all the money you guys have, why wouldn't you just buy like a decent trading platform so people can just do some stuff, you know, like so you don't have to do all the crap you got now. He's like, you know what? I don't know. He's like, we have toyed with it, but I have no idea. He's like, I don't understand why we don't have anything better than we already have. It's unbelievable. I'm like, yeah, I know. I know what the guy once told me at TD Bank in Canada. He was the CEO of TD Bank in Canada. His name was Ed Clark, really, really brilliant guy. And at the time, he was the CEO of TD Bank. And I said, you know, your technology is just so bad. Why don't you guys just spend some money? And you got $100 billion. You know, go spend just a little bit of money and go buy a decent trading platform. You know, this is before they bought our stuff. And he's like, do you know how much money I make on trading? I go, I have no idea. And he goes, nothing. Right. That's why. He goes, you want to know why we don't buy a trading platform? We don't make any money. He goes, you know. He goes, it's not worth anything to us. I'm like, okay, I guess that answers my question.
Yeah.
You know, he goes, like, we give away more money than we make trading. So, all right, I'm fine. That'd be your business. You know what stock's up big today? And I put a position on there this morning, and it was
Soft?
No, this was the first position we put on this morning. I believe it was Kai, and it was Rivian. Rivian was down this morning. It was trading about 19 and a quarter.
Wow, up $1.30. You are correct.
Yes. Very strong move in Rivian. We have a position on in there. We are short the.
It's making its highs right now. It opened at $20, so $1.70 lower.
Yeah. No, Rivian is strong like bull.
Yeah,
we're going to roll up some 17 and a half puts.
Already on day one?
No. This is from a different position I had on in there.
Oh.
I had a bunch of different positions on Rivian. I'm going to roll up some of my 17 and a half puts to 20, which I can't believe because about a month ago I was thinking this stock's going to zero.
Yeah, you did the straddle, the 17 limit strength.
Yeah.
I apologize.
Yep. Yeah, this was a day that kind of, you know what, I'm not going to lie, messed me up a little bit because when they're down 65 in the morning and the implied volatility is up by 10%, I'm not looking for a reversal.
Yeah, but this is not a power back either. I mean, I know we were down 60 some odd on the handles on the E-mini S&Ps, and you're down 35 right now on what seems like just short covering, walking them up kind of thing. I would think we would have a little bit more weakness overnight tonight. That would be my guess. Volatility, although it has gotten squashed or cut in half or more, still up almost 6%. I don't know. I think you still got a little bit of more.
I don't know. It's a lot stronger than this morning. I would have bet that they're not closing where they're closing right now. This was a major. There were a lot of double whammies today. There was all the zero traders got caught today, and if I was adjusting if I had a zero position on it, I was adjusting it, I would have adjusted hard to the downside, and they rallied all the way back.
Yeah, well, you're Johnny. Sure, I get it.
Guess.
I get it.
I guess.
No weak hands, paper hands.
What'd you call me?
Paper hands.
Paper hands?
Yeah.
Oh,
Bring
man.
back the old memes. Yeah. Yeah, paper hands. You sound great. You gonna be good for this weekend?
I'm gonna be fine.
Got
Paper hands. I don't like that nickname.
You don't like that new name?
I don't like that name, Paper Hands.
I'm sorry.
No, I don't like that name because that's not me.
Well, I mean, you didn't buy him down 60.
I said I wanted to sell him down 65, not buy him.
I know. You want to sell him down 65, but you don't want to sell him down 35. Exactly.
Exactly.
I know.
Exactly, because that's how my mind works. Yeah, Microsoft saved the market today.
I said that to you. Microsoft saved
Microsoft.
Bitcoin 30,300. Coin's still weak today too, after being up.
Actually, coin is relatively strong given where Bitcoin
unchanged
closed.
for the day. Yeah. Mm-hmm. Yeah, $4 off of its highs, but also trading right. I guess $4 off its lows. We're trading right near its highs. Yeah, you're right. Actually, throws down $2. It might have been just a moment ago. It may have rallied a little bit.
Yeah.
Less than a minute. Say something profound to me.
Less than a minute. I mean, I'm a little bit short here going home tonight, but our theta's kind of low. Our extrinsic's decent because we rolled. So our extrinsic's really high. Our theta's kind of low. Our deltas are a little bit short. I'm mostly short NASDAQ, and I think that's what you got to stay short. You got to stay short NASDAQ. And I bought a little bit in bonds today. But again, the biggest winner today was the yield curve. For the second straight day, the yield curve moved huge. That's our best trade on the board today.
Beautiful.
Finally, after like 3 weeks, no uptick. Spoos down 37. Pretty much didn't move all
Could
afternoon.
have made $2 if you would have just sold them. We'll be back in 90 seconds. Listen to Tasty Live. Frank Caberna next. Peace.
Hey, you. Yeah, you. You deserve a big bonus and a better broker. Now, when you open and fund a Tasty Trade account, you can get up to $3,000. Have it all with Tasty Trade. Low rates, lightning fast technology, a live in-app trade feed, and award-winning support. You deserve it all, and you can get it. Plus, up to $3,000 when you trade with Tasty Trade. Head to tastytrade.com/tasty-offer for more details.
The beautiful thing about talking to entrepreneurs is that they have the ability to maintain their positivity and their confidence when they know what and they know why, but they don't quite yet know how. And they're willing to take not only their own risk, but sort of to organize people around their idea and enroll them in the idea to try to bring it to fruition. And I think that there's something that's very appealing to me about people that are willing to transition from talk to action. Watch Bootstrapping with Dylan Radigan on Tasty Live.
He's a senior in high school.
Okay, cool.
He has $25,000 from working. That's amazing. Do you think it's best for him to stick with defined risk or undefined risk strategies?
The term undefined risk is a really crappy term. Undefined risk strategies have a higher probability of success. Defined risk strategies have maybe less risk. I prefer undefined risk. He should mix them up.
Any percentage, like weighting, like 60-40, 70-30? Like,
I mean, I'm 75-25, undefined over defined. He can be whatever he feels comfortable with. He can be 75-25 defined or 75-25 undefined, or he can be 50-50, anything he wants.
How we respond to the most difficult situations is ultimately how we learn to build on our successes.
It takes the guesswork out of retail trading.
Hello, trading friends, and welcome back to the Tasty Live Network for a special Thursday edition of In This Economy. I'm your host, Frank Caberna, guiding you on this nearly end-of-week tour of our economic organism as it shifts back and forth in advance of a non-farm payrolls to close out a relatively short week if you're trading here in the U.S. with the 4th of July holiday. A weird week with it being on a Tuesday, but we're up and running and markets are a-moving. So let's get into our biggest movers of today. And then we're going to wrap about a few interesting things. I mean, I think that they're interesting and you're watching the program. So you are unfortunately at the behest of Frank's interests for the next 30 minutes. But yeah, we're going to talk about the non-farm number that's coming up, whether a positive number is necessarily good or bad for the economy, a very awkward moment to be a non-farm number. And then we're also going to speak to how the British pound is taking over the Forex space for the last couple of months here and why that's happening and what that could mean for the future of not only the US dollar, but other asset classes as well. And you can see here that the pound is outperforming today as well. In Forex world, pound up 0.4%. That is the best performer against the US dollar. On what's a mixed bag, we have Canadian dollar lower by more than 0.5%. And this has been the theme of recent Forex trading, which is the US dollar isn't getting hit too hard. US dollar is actually at highs against Japanese yen and Australian dollar, at least near them, that is. But the pound is beaten up on the US dollar, and as well as the yen, as well as the euro at this point, as US dollar bullish days, the pound is either the only one that's positive or it's not doing that bad. In US dollar bearish days, the pound has been the outperformer. So your next trip to London might be a little more expensive, but of course we're going to go past that into price action, what it means for the economy, and what potential trade is there. As you'll remember that, yeah, the pound is back to almost $1.30, but that's off of lows of $1 and a nickel last year that we hadn't seen in the British pound in years and years and years. So outperformance, but from historically low levels. So we'll see what it all means in just a second. What does it all mean in the agriculture space? Corn's up 3%, wheat's down 3%. Ags can't decide which way they want to go, as they're both the top performer and worst performer of the commodity asset class here today. It's been a rough ride for wheat. It's been a rough ride for ags, but especially wheat. If you take a look at that chart, down significantly from the highs of last year. And there's a general trend to be made between agriculture markets and energy markets, both of which peaked at the height of the Russian-Ukraine conflict, as supplies of both wheat and crude oil are affected by that conflict. And there was a lot of uncertainty, obviously, when it was first coming out, similar to the pandemic coming out in 2020, and that great uncertainty shocking the stock market lower before settling in and understanding that, of course, I don't want to make light of it, the pandemic and Russian-Ukrainian war, awful on a personal level, but markets, as they got a few months away from the initial news of both, settled in a little better. The stock market bounced back, and crude oil is off from $120 to $70, and wheat has gone from its highs to its lows very, very quickly. And you're hopefully seeing that reflected in gas prices at the pump and food prices at your local grocery store. But either way, turning into a really rough ride for ag markets. And we're in the heat of summer, where seasonally agriculture markets are more volatile, and that volatility has been pretty one-sided, and that's downside recently. In the stock market, as you can see, the best performer in the S&P 100 being Microsoft, the rich get richer, so to speak, only being up a percentage point, and the worst performer, PayPal, the weak get weaker, sorry, down 4%, lets you know all you need to know about today's market, which is the majority of stocks in the red, the focus being in the red. And this is so, I maybe nerd out too much, but what you love about math and distributions and everything else is in the stock portion of this segment, the biggest movers, we look at the S&P 100 stocks and find the outperformer and the underperformer of the S&P 100. And the S&P itself was down about a percentage point today, which is almost exactly the midpoint of its top and bottom performer here, which are all probably semi-normally distributed throughout this area of up 1%, down 4%, the majority of them focused around down 1%, essentially the midpoint there, like I say, and that's where the S&P 500 is. Does it mean anything? No, but it's always premise of this show is connecting all these different things throughout not only the stock market, but the economy at large, to hopefully send you on your way with some more information for your next trading strategy. And just interesting how that plays out. Was a rougher day for the stock market, but able to bounce back a little bit. And Microsoft shrugged it off, as well as Meta. Like I say, those strongest stocks of the last few months here have just been getting stronger, and PayPal has had a rough ride. PayPal, essentially the wheat of the stock market. You heard it here first. But let's move on to our main segment for today. Why job growth is bad for the economy. Of course, job growth, all else equal, is a positive thing. But in today's economy, job growth being up, more jobs entering the U.S. market than leaving the U.S. market, is a lot more nuanced these days. There are some negative pieces to it that I'll highlight and could conclude in job growth turning around to the negative. We'll go full circle on this, how essentially job growth in 2023 could essentially conclude in job losses in 2024 or beyond. Of course, the timing of these things always difficult, but a really fun segment that we're going to speak to today. And it's no coincidence that July's non-farm payrolls for the last month of job growth come out tomorrow. They're expected at 225,000. That is much lower than the reading that we got in June for May. The reading then, as you can see here, I've highlighted, this is what the actual document looks like from the U.S. Bureau of Labor Statistics, came out at around 340,000 last month. Nearly 30, 40% higher than this month's expectation. And that was a surprise to the upside. And we'll get to what that meant for the stock market in just a second. But the expectation here, not only lower than last month, but expected to be the second lowest reading in the last year plus of non-farm payrolls. The lowest measure in the last year was 217,000 jobs. As again, the lowest number being a really positive number, over 200,000. The economy has, and this is all synergetic with inflation, right? Jobs are flying around, money's flying around, inflation increasing the price of goods as more people have jobs, more people have money, and so on. And hopefully you can see kind of where we're getting at to in a second, because that inflation increasing has its effects on interest rates and then leading back to stocks, which we'll get to in a second. But let's actually start with the most immediate effect that we tend to see. In June's surprise, essentially more job growth than was expected but coincided with the S&P 500 making new highs year to date. You see here we highlighted that day, and that was when the S&P 500 had made a new year-to-date high, a new high since the fall of 2022 there, falling on the same day. And so non-farm payrolls being a big weighty number that tends to cause reaction in every asset class, especially interest rates that we'll get to in a second. But I think relatively easy to make a case between these two events coinciding, non-farm payrolls coming out very, very positive, the stock market making year-to-date highs. And that is the short-term mind on this. It's what you would expect almost, right? Like, yeah, we get a good data point, the same as, GDP higher than expected. We're producing more. There are more jobs moving around than expected. That is a sign of, on the consumer level, there's probably more, money, better sentiment, but also on the business level, the corporate level, whatever you want to call it, people are hiring more. And that is, in a vacuum, a positive thing for the market at large. But this also has coincided with the yield curve getting back to an inversion of negative 100 basis points. You can see here that we put in a low. This is the 2-year versus the 10-year. got all the way down to an inversion of negative 100 basis points or negative 1% in March, April range, turned around, headed back towards normalcy, which did coincide with, you'll remember March, what was going on then, the regional banking crisis, which was an inherently negative thing, and we'll unravel that in a second here. But as jobs came in last month better than expected, more job growth than expected, we actually took a turn for the more inverted. And now we're sitting at, as of yesterday, the largest inversion in the yield curve in 30 plus years. And you'll see that not only were the past inversions that we've seen in the yield curve, if you can see the yellow or orange line climbing above the blue line, that is a yield curve inversion. That's short-term rates jumping on top of long-term rates, literally the definition of a yield curve inversion there. And you'll see that that orange line climbs on top of the blue line there in 1999 2000 range. What happens right after that? The dot-com bubble bursts. The next time that you see that is in the 07, 08 range. What happens in 08? The financial crisis. Now, I don't want to jump on here and say one necessitates the other. Of course, that isn't true. Otherwise, the stock market would have already crashed, right? It's efficient like that. If it knew that inversion means that we have to crash, it would have done it the moment that the yield curve went inverted. But you can't help but look at this small sample size and say, I mean, these things happened in around the same time. And so I want to just quickly flesh out what's actually happening here, what happened in the past and what's happening now, how they're similar, how they're different. They're similar in that short-term rates cause inversions. They have the last couple of times, they are causing it this time. And what I mean by that is short-term rates are running up really high, and that's why they've caused this inversion. They've climbed higher than 10-year rates. Theoretically, you could see a yield curve inversion whereby interest rates are moving lower and 10-year rates just move way lower than 2-year rates. We don't have a data point for that. It hasn't occurred in at least the last 30 years that the U.S. Treasury has provided me data for. So with that being in mind, what's happening? Well, the reason that the stock market isn't crashing, even though that we're inverted and historically inversions have coincided with stock market crashes, is because we're inverted for a very normal and explainable reason. Inflation has set in the last year or two. The Fed, the central bank, they monitor inflation. That's like their number one thing that they monitor. They want to keep it not too low, not too high, medium, around 2%. And as inflation ran up, the central bank said, okay, well, we need to slow this down. We need to slow down our economic expansion, go into a contractionary period. What's the number one tool that they have? Short-term interest rates. They raise them to slow that down, bring that inflation back in line. And so at the same time, the central bank is saying, we see this inflation as being a serious problem. That's why we're acting. That's why they've hiked interest rates from 0% to 5%, and are playing at the fact that they might hike them another, half a percentage point to who knows, the market, we will see how high they get. Could be 6%, could be beyond. But they also have been saying inflation is transitory. They see it as being a couple of year process. And so if you're the 10-year or 30-year interest rate, you have been moving higher in tandem with short-term interest rates moving higher, but you're not fully buying in, right? Like if they said, oh, we see inflation is going to be a problem for 10, 20, 30 years, and so we're going to keep short-term interest rates that high for that long, then you would probably see the 10-year and the 20-year and 30-year bond move higher as well, and maybe that would unravel the inversion. And that could still unravel the inversion. But what we have seen, and this leads to the potential for a bigger job number being potentially negative for the economy, what we've seen in the past is short-term rates cause inversions, and they have also resolved them. And what I mean by that is 2-year or whatever short-term interest rate benchmark you want to look at. Here we're looking at the 2-year. causes the inversion by running up high and fast. And then the last two times we've seen this inversion, there's been a stock market crash, some instability that you could partially peg to interest rates moving too high too fast and the economy not being able to digest that, companies, stocks, and everyday people not being able to digest that. And then the stock market has turned lower, and then the central bank, the Fed, has done the exact opposite of what they did in prior years. They've moved interest rates lower, and thus the inversion resolved to a normal environment where short-term rates come crashing down and longer-term rates move lower as well, but not by as much of an extent. Similar to if you are around options markets and volatility indices, you'll see sometimes if a big shocking event occurs, like the pandemic in 2020, short-term volatility will scream higher and medium-term volatility will move higher, but not by as much. Longer-term volatility will move higher, but by the least amount. It's a similar process here to the upside and downside. So what does this all mean about job growth? If the job growth number comes in better than expected, could, in the short term be good for the stock market. It moves higher on this Friday or in the next week or two or potentially months. But that would be a sign of, greater inflation, a need for higher interest rates, and an even greater yield curve inversion. And historically, we've seen these yield curve inversions only be resolved by a crash, which leads to negative job growth and a whole mess of problems there. So, of course, one doesn't necessitate the other. We'll see what happens with this non-farm number that is due here. But, job growth in this very nuanced economy could be potentially bad for it in the future. Forex Focus brought to you by IG, a real fun segment here today on the British pound and why and how it's become one of the strongest currencies in the major currency market here. We're talking about basically pound, US dollar, euro, Japanese yen, and you throw Canadian dollar and Australian dollar in there. And that's purely judging by GDP of those regions. But of those, major currencies that make up the major Forex pairs, pound has been on a hell of a run here. You might, on the face of it, say, hey, 127, that's not really historically a high value for the pound against the dollar. But, that's 2,000 pips, more than 2,000 pips higher than the 2022 lows of 105 that we hit in September of 2022, or 20 cents higher, however you want to call it. That's a really big move in what's been less than a year. Forex pairs tend to trade with a volatility around, anywhere from 5 to 20%, which lets you know that in a year, they would move maybe 5 to 20%. And you can see here more than 20 cents higher from 105. That's already about a 20% move. So you're seeing the upside of historically volatile ranges for this pound dollar. And that's a developing story here. The pound and the dollar seem to be competing for who's strongest currency of those majors. Because you rope in the yen, and you're seeing a pound right now that's trading right at multi-year highs against this yen. And I believe this is going back to the 08-09 range, trading above 180 for the first time in years. And you might say, well, yeah, the dollar's been beaten up on the yen. The euro's been beaten up on the yen. Yes, true. But the dollar's not through its highs from last year against the yen. And you can see that pound is, right there at those highs against this yen is a really historical extreme that we're currently seeing pound beating up on that market. And throughout the first part of this year, pound and euro were both bouncing back against US dollar, give or take performance in a given week. Sometimes the pound would bounce back better, the euro bounce back, and kind of trading hands, so to speak. In recent trade, pretty much since, middle of April, start of May, the pound has been gaining on the euro, and they're obviously more highly correlated as they're very near to each other. Their economies are very interdependent in many different ways. But yeah, trading down to 85 cents here for the first time since summer of last year, as it's been a general trend lower for euro, higher for pound, near those year-to-date lows as we speak. And that's a context for what might make the pound right now the strongest currency. It's appreciating against most of the other major currencies. But, why is this occurring, and what could incentivize a reversal of this trend or a continuation of this trend? Well, I crunched some numbers on the stocks of some of these major economies, the S&P 500, US focused, EWJ, Japanese stock ETF, EWU, UK stock ETF. And it's not stock performance, because the S&P is up more than 15% year to date, and UK stock market from this perspective, EWU's perspective, is up less than 2%. And so relative performance between stocks in these areas, definitely not in the UK's favor. I mean, Japanese stocks are up, quadruple what UK stocks are up year to date here. So it's not that. And there's always been a looser tie between stocks and currencies. That's why they make great diversification partners, is because stocks being up, down, or sideways don't tend to lead to a currency doing X, Y, or Z. What does have maybe a more direct effect on the British pound's outperformance recently is its higher inflation than any of these major economies, at 6.5% core inflation here, relative to 5.4%, 5.3%, and 3.2% of these other majors. And that makes sense, right? Because these inflation rates drive global interest rates. And though US rates are still slightly higher than UK rates, I think a lot of this move is of British pound being higher, appreciating in recent trade, is under the idea that the market is starting to price in that the UK not only has higher inflation right now, but could have higher interest rates in the near future. Inflation driving interest rates, which usually drives Forex demand. Of course, these numbers don't all live in a vacuum. Inflation can be higher in the UK. Interest rates might move a different direction, or currencies might move in any direction that they want. But this has been a general trend that we have seen historically. And if UK inflation does stay higher than these other major regions, and the Bank of England does hike interest rates higher than the Euro area, US, or obviously Japan's still at negative 10 basis points in their interest rate, then you could see further demand in the British pound. Of course, on the flip side, if UK inflation moved higher than these other regions at a faster pace and then cools off at a faster pace, then maybe they'll be cutting interest rates, moving interest rates lower, and the British pound reversing there. But either way, you have this interesting strength in British pound for the first half of 2023 here. You have a bunch of inflationary data and interest rate decisions coming up. And if you have an opinion on where inflation might be stickier here in the US versus the UK or the Euro area or Japan, what have you, then you have some interesting trades and potential strategies in front of you. And that'll do it for today's episode of In This Economy. Thanks, as always, for watching all week, my friends. Have a great weekend, but stay tuned to the Tasty Live content coming your way. Have a great trade, everybody. Peace.
Rock, paper, scissors? He just played paper.
Tired of planning around your stuff? With Bounce, you can find a place to store your bags in any neighborhood. Bounce partners with local hotels and shops to give you instant access to secure storage spaces all over town. Simply open the Bounce app or go to usebounce.com. Search locations nearby, instantly book your space, and then walk over to the shop. They'll tag your bags with Bounce security seals and store them safely. $5,000 of coverage is included in every booking. Have peace of mind knowing your things are always safe with Bounce. Now, you're free to roam around the city without your things holding you back. Bounce gives you the freedom to experience more of the things you love. Bounce is the largest luggage storage network in North America, with over 1,000 locations across more than 100 cities. In 2020, Bounce will be available in Europe and beyond. We are so excited to bring you ultimate freedom in your travels. We have 24
When you're staying at a hotel, it's easy to have them hold your luggage before or after your stay in case you want to explore a location without lugging around your bags. However, what do you do if you stay at an Airbnb or even just enjoying a long layover or stopover? Hey, how's it going everyone? It's Ernest. We have lockers due to security concerns, and with lodging options, you maximize your experience through travel tips. Comparison, I'll also compare whether each of these cities to provide storage or locations. Tokyo and Paris also had no locations listed. Bounce does provide details. Luggage Hero has partnered with hotels, cafes, and local stores to provide a safe and secure location to store your bags. It's a $3,000 insurance coverage. They also provide 24/7 customer service through a chat line. However, they don't have your space to store your bag. It's worth noting that Stasher has some significant endorsements and partnerships listed on their website. While it doesn't mention your name, since I'm familiar with LA, it's the lowest of all. There are a lot of people to start with your bag, since you'll likely get cut by baggage inspectors into an area where you might have a higher risk of crime, especially when you're carrying all your luggage. While getting exact crime statistics can be tough, you can generally find safety information online. Sites like safearound.com can give you information on areas to avoid during the day and night, as well as specific warnings and dangers for cities around the world. Have you ever used a luggage storage service? Do you have any other tips for storing your luggage while traveling? Let us know in the comment section below. If you enjoyed this video or found it useful, please give us a thumbs up and consider sharing the video with others. It really helps us grow our channel and community. Also, if you want to see the diagrams used in the video, I posted them on the website. Until next time, travel safe and travel smart.